we're going to try and solve this using a few techniques. Let's begin by trying to bring these logarithms together, trying to move things around in such a way that makes this a bit easier. So first of all, let's bring the x up using that third law of logarithms. We can write that first expression as log base 2 3 to the x. Now the reason I did that is because now I can bring these together. Yeah, I can bring them together in one expression. So this is going to be log base 2, and we're going to have 3 to the x multiplied by 36, just like that. Yeah. Okay, and that, of course, is equal to 2. Now, first method of solving these, well, once we've got this, you need to try and say this to yourself like you would any other logarithm. So this reads to me, what is it I raise 2 by to get 3 to the x times 36? I raise it to the power of 2. So convert it to its equivalent exponential equation, right? 2 squared is equal to 3 to the x times 36. So let's do a little bit of simplification here. Well, if we divide both sides by 36, I mean, 2 squared is 4. So we'll have 4 over 36 equals 3 to the x. And 4 over 36 is going to be 1 over 9 equals 3 to the x. And from here, I can solve it myself. Well, 3 to the minus 2 is 1 over 9, and we're done. So the first method to consider, bring things together, and when you get to a stage like this, swap it out for an exponential equivalent expression, and then things are often a lot easier to solve. Let's look at another strategy now. So in this case, the thing to do to start with, to me, it certainly looks like it, is to bring the two terms on the right-hand side together. So let's do that and see what happens. Log base 5x is equal to log base 5 of 8 over 6 minus x. I'm using that second law of logarithms. Now, from here, we've got a different strategy to use because we've got log base 5 of x equals log base 5 of 8 over 6 minus x. Well, to me, that implies that x is equal to 8 over 6 minus x. Log of this is log of that. We've got the same base, so therefore those things inside those logarithms are the same. So second strategy for solving these, make both sides have the same logarithmic base, and then you can kind of drop the logarithms together. So if we go from here, let's multiply both sides by 6 minus x. We'll have 6x minus x squared is equal to 8. Let's put it all on the right-hand side and form a quadratic equation. It's going to be something like that, and I guess we can solve this one quite easily by factorizing. This will be x minus 4 and x minus 2. So therefore x is equal to 4, x is equal to 2. I should say we've got to be a little bit careful. We just go back and make sure that we get positive outcomes when we get with these two numbers go into these expressions. Yeah, log 5 of 4 works. Log 5 of 8 over 6 minus 4 or 6 minus 2, they work. If we were to get a negative number inside that logarithmic expression, it wouldn't make sense. Think about negatives. What if I raise 5 by to get a negative? Well, there isn't anything. Okay, it makes no sense. So we just got to be a little bit careful to check with these. But those are our two solutions, x equals 4 and x equals 2. Now, to go any further with this, we're going to need a new law. We're going to need some new brain cells and some new strategies. So the next thing to think about is a little subtopic called changing the base. And we'll need to prove a little result. So let's start off with some basic assumptions. Let's say that b to the x is equal to a, and this has its equivalent logarithmic expression. Log ba is equal to x. Okay. Now, we'll start, in fact, though, with the original. B to the x is equal to a. Well, let's put these in a little box out of the way. Well, what I'm going to do is I'm going to take logs of both sides, right? If that's true, then let's just use some other base. We'll call it c. If I take log base c of this side, that is going to be the same as log base c of the other side, right? Log c of bx equals log c of a, if b to the x equals a. And from there, I can use the third law and bring the power down. So x is going to be log c of b over there, look, and we'll have log ca still on the right. So dividing through, I mean, these are just numbers. X is going to be log c of a over log c of b. And we go back to the beginning. We do have an expression for x in terms of our logarithms. We derive the following result. Log ba equals log ca over, excuse me, let's write this nicely for you. Log c of b. Now this is, if you like, the change of base formula, and we can apply this to all sorts of situations. And just to be clear, how I use this is in the following way. If I have log, I don't know, 820, just for example, and I want to change this to base 5, it's going to be log base 520 over log base 5 of 8. This gives us a lot of freedom. We can change the base to be anything we want. So with that in mind, let's take a look at a few more examples. So in this expression, or this question I should say, we have got a base 2 here and a base 8 here. Now we're not going to be able to solve anything until we have done some work to get those bases to be the same. So I think in this case, we can do it both ways around. Let's turn everything to be base 2. So the first part can stay exactly as it was, log base 2 of x squared. The second part, though, is going to be a little bit different. We're going to write this as log base 2 square root of x over log base 2 of 8. And that is just a straight swap out using our change of base formula. We'll keep the 3 on that right-hand side. From there, well, we'll keep this log base 2 of x squared as it was. Now, log base 2 of 8, the denominator of this fraction is 3. So this is a bit like having a third at the front, and we'll keep that top numerator as it was. Maybe we could write the square root of x as x to the power of a half. But other than that, just exactly the same. And from there, we can kind of bring the third up using the third law of logarithms. Log base 2 x squared plus log base 2, and it will have x to the half to the power of a third. Well, we'd multiply those together. We would have x to the power of a sixth is equal to 3. And you've probably guessed what to do now. We can bring those two expressions, they've got the same base, so we'll bring them together and we'll write those as log base 2 of x. And we've got 2 plus a sixth, so we'll write it as 13 over 6 is equal to 3. There we are. Now from here, we can just say to ourselves, well, what is it I raise 2 by to get x to the 13 over 6? I raise it to the power of 3. So we'll have 2 cubed is x to the 13 over 6. It looks a bit complicated, this, but it's okay. So from here, I guess we can just sort of flip it around. Imagine raising both sides to the power of 6, and or raising both sides to the 1 over 13. You're going to cancel out. Either way, with the 6, we're going to get an 18, and that 13 on the bottom there as well. So our answer is x is going to be equal to 2 to the power of 18 over 13. And we'll leave our answer there. We'll keep it exact. Okay, another question. Let's have a look at another one. This one, we've got bases of 27 and 3 going on. So to me, it would make sense to try to write everything here as a base of 3. So if we do that, we will end up with the following. Log base 3 of x to the minus 1, which is the number inside the brackets there, over log base 3 of 27. And of course, we'll keep this second term exactly as it was, equals log base 3 of 10. And then we will say, well, okay, what do I raise 3 by to get 27? It's 3 again, much like last time. So much like last time, we'll bring that outside, log 3x to the minus 1. And now we can bring that third up. We'll have log base 3 x to the minus a third plus log base 3 x to the 4 equals log base 3 of 10. And now we're ready to bring those two parts together in one expression. We're going to have log base 3 of x to, well, think of that 4 as being 12 over 3, so we'll have 11 over 3 equals log base 3, 10. So if that's the case, we've got log of this is log of that, we can drop the logarithms completely and say that we've got x to the 11 over 3 is equal to 10. So with that in mind, again, we can kind of flip it around. We can cube both sides, and then we can, at the 11th root of both sides to give ourselves the answer x is equal to 10 to the power of 3 over 11.